present video, I will show about the how to calculate average value as well as RMS value for the different waveform shapes. For example, I am considering the following problem, that is calculate average value and RMS value for the following waveform. That is, we have to calculate, consider voltage waveform and x-axis time. I am taking sawtooth waveform here. The maximum value is, I am considering 100, and the time period is 2, 4, 6 and so on. Okay. For this waveform, you have to calculate average value and RMS value. Before going to the formulas of average and RMS value, you must find out what is the time period of the given waveform. In the above waveform, the time period is 2 seconds. Why? Because after 2 seconds, the same waveform will be repeated. That is continuously repeated at particular instant of the time. That is called the time period of the given waveform. So here, in this example, after 2 seconds, the same previous waveform will be repeated again. That's why the time period is 2 seconds. Hence, the time period 2 is, the time period t is 2 seconds. Then, before going to the average value, we must find out what is the equation of the function variable. Here, the given variable is voltage V. Then here, in this waveform, it is not a sine waveform. To directly write down the equation of sine, okay, it is a straight line. That's why, first of all, you have to verify what is the points of the straight line. Okay, in this waveform, the straight line will be points are 0, 0, 2, 0. That is, here it is x1, y1 and it is x2, y2. We have 2 points are there. Between the 2 points, we must find out what is the equation of the line. We know what is the formula for equation of the line, that is y minus y1 equal to y2 minus y1 by x2 minus x1 into x minus x1. Okay, x1, y1 and x2, y2 are the points, and y is the y-axis variable, and x is the x-axis, t is the x-axis variable. Okay, here you can replace all values to find out the equation of the straight line here. Then y is nothing but y-axis variable v, and y1 is 0 and y2 is 100, y1 is minus 0 by x2 is 2 and x1 is 0 into x-axis is t minus x1 is 0. Then what is the equation of the line here? That is v of t equal to 100 by 2, that is 50 into t for 0 less than t less than 2. So this is the equation of the given waveform, that is v of t equal to 50 into t. Then we have to find out after finding equation of the line, then you must find out what is the average value of the given waveform, that is v suffix average equal to, we know the formula, that is 1 by t integral 0 to t, the function is v of t and dt. Then what is the time period here? 1 by 2, t nothing but 2, then 0 to 2. Now what is v of t here? That is 50 into t dt. Here 50 is constant, 50 by 2, 25, and for t, integration of t we know, that is t square by 2. Then the limits are 0 to t. We know the integration of t is nothing but t square by 2. That is t power n. Integration is t power n by n plus 1 by n plus 1. From that, here 20 by 25 by 2. 2 is constant. Then apply the limits here. 2 square minus 0 square. That is 25 into 4. 100 by 2. That equal to 50 volts. So that is the average value of the this corresponding given waveform. In the same way, you have to find out what is the RMS value. That is, we can denote VRMS. We know the formula 1 by t integral 0 to t v of t whole square into dt for the function whole square root of, that is root mean square value. Okay, from that apply the values here. T value is 2, we know, and 0 to 2. What is the v of t value? 50 into t whole square dt. For the whole, there is a square root value. Then 50 square, 50 square by 2 is constant. Then t square. For t square, what is the integration? T plus 2 plus 1 by 2 plus 1. That is t power n. Integration is t power n plus 1 by n plus 1. Here, in place of n, we have 2. That's why 2 plus 1 t cube by 3. Then the limits are 0 to 2. Then square root of here. Then 50 by 2 is the 2500 by 2, and 3 is constant taken outside, 2 into 3. Then apply the limits here. 2 cube minus 0 cube. Then whole square root. That is, what is the value here? 2500 into 2 cube is 8 by 2 into 3 whole square root. Here 2 power 4. Then 25 into 100 into 100, 25 into 4 into 100 by 3 whole square root. Then 5 into 2 into 10. Apply the square root. 5 into 2 into 10 by root 3. That is 100 by root 3 volts. That is the RMS value. So for the given sawtooth waveform, you have to find out average value, RMS value like this. That is, you must know, find out what is the equation of the straight line. If the waveform is given sawtooth or triangular waveform also, then you must find out what is the equation of the line. After that, find out average value as well as RMS values. In the similar manner, by considering another example, same, find out average value, RMS value for the given waveform. For example, the given waveform is full wave rectified waveform. Okay, this waveform is very most important. Most of the final examinations here this waveform will be given. That is full wave rectified waveform. That is only the waveform sinusoidal waveform consists of positive half cycles. Then the negative half cycles will be 0. X-axis taken as t here and y-axis taken as I, and then the maximum value is Im. The time period is pi, 2 pi, 3 pi, 4 pi, like that. Okay. For this waveform, you have to find out what is the average value and RMS value. Okay, this is called the name of the waveform is called here full wave rectified waveform. We know the rectifier having two types. There is a half wave rectifier and a full wave rectifier. Okay, that is for half wave rectifier. We know the waveform that is only having positive pitch values like that. Okay, this is the half wave period, not full. Okay, I am taking here. Okay, full wave rectifier means here all wave positive and negative values waveforms should be getting positive values. Okay, this waveform is the example of half wave rectifier waveform. Okay, full wave means in brackets I am writing here that is full wave rectifier output is nothing but the sinusoid waveforms all peaks are positive. Okay, this is called full wave rectifier. Only having positive peaks and negative peaks are zero. That is called the half wave rectifier. All peaks are positive. That is called the full wave rectifier. Okay, these two examples are very most important in case of university examinations. Okay, then in the above waveform there is a half wave rectifier. You have to consider this is the sinusoidal waveform. Then what is the equation? That is I equal to Im. We know the equation of sine nothing but sine omega t. In the waveform, x-axis is given t. That's why sine t in the range of 0 to 0 less than t less than pi, and other value I is 0 in the range pi less than t less than 2 pi. Okay, that is here in the given waveform we have only pi here. Okay, after pi there is no waveform shape, that is 0 value. That's why 0 to pi it is sine waveform, and pi to 2 pi it is value 0. That's why we have two values are there. After again 2 pi the same waveform will be repeated. That's why the time period t is nothing but 2 pi in the half wave rectifier. In the half wave rectifier the time period t is nothing but 2 pi. Okay, we know the equation of the given variable, and we know the value of time period. Then find out the average values and RMS values for the half wave rectifier. Therefore, average value equal to, we know the formula, that is 1 by t integration 0 to t. Here given the variable is I, x-axis is t, that's why dt, that is 1 by 2 pi. Then we have two ranges here, 0 to pi. The value is Im sin t plus again other range pi to 2 pi. The value is 0, that is dt here. So this is the complete function variable. Then 1 by 2 pi Im is constant. Then I am writing outside. Then what is the integration of sine? We know that is the integration of sine is minus cos theta. That's why the limits are 0 to pi. Other function is 0, second function. That's why total function is 0. For cos, minus is, I am writing outside, that is minus Im by pi. Then apply the limits cos pi minus cos 0. We know the values of cos pi. Cos pi is minus 1 minus cos 0 is 1. That is minus 1 minus 1 minus 2. Then the value is, here the time period is 2 pi, not pi. Complete total time period is 2 pi. That's why 2 Im by 2 pi. Then 2 is cancelled. The average value is for half wave rectifier is Im by pi. Okay, this is the formula for average value of the half wave rectifier output waveform. Similarly, in the same manner, we have to find out the RMS values also for half wave rectifier. That is IRMS. The formula is 1 by t integration 0 to t I square dt. For whole term, there is a square root. Then time period is 2 pi. We know the between 0 to pi, we have two ranges. 0 to pi, what is the I value? That is Im sin t. From again pi to 2 pi, what is the function value? 0 into dt. Here also dt. Then this is the given. So for whole the function, there is a square root is there. Don't forget to write down the square root. In examinations, most of the students are forgot to write down the square root here for every step. That is 1 by 2 pi. Second function is 0. Then Im is constant. What is the, okay, here we have I square. That's why in the RMS value, the formula is I square. Then Im sin t whole square. Im square is constant, writing outside Im square by 2 pi. Then what is the formula for sin square theta? We know sin square theta, the formula is integration 0 to pi 1 minus cos 2 theta by 2. So for sin t, sin square t, the formula is 1 minus cos 2t by t. This is the formula for sin square theta. Other second function is 0. That's why it is 0. 1 by 2 is constant. Im square by 4 pi. That is 2 written outside. Then for 1, the integration is t. For cos, the integration of sin 2t. Again 2t, the differentiation is 2. That is by 2. Here we have cos 2t, not cos t. For cos t, the integration of sin t. Okay, the integration of cos 2t, nothing but sin 2t by 2. Okay, for the whole function, apply the limits here. That is Im square by 4 pi minus sin 2 pi by 2. That is first value. Second is 0 minus sin 0, also 0. This is second limit value. Then sin 2 pi also 0. We know that already I am told about. Don't forget to write down the square root in every step. Then Im square by 4 pi into pi. Then pi will be cancelled. Im square by 4. Nothing but the value is Im by 2. That is 0.5 IM. Okay, this is the value of RMS value of the half wave rectifier output. That is the sinusoidal having only positive peaks. Okay, the negative peaks value will be 0. Okay, like that you can also find out what is the average value RMS value for the full wave rectifier also. Okay, in this example just I am showing about only how to find out the function value for full wave rectifier. The other example is, that is full wave rectifier, only the output having positive peaks. There is no negative peak here. That's why it is pi 2 pi. What is the time period here? The waveform will be repeated after pi. That's why the value of time period is pi. The value of time period is pi. In the same way, suppose the given function is V, voltage, that is x-axis also suppose t. What is function value here? V equal to maximum value Vm, that is Vm sin t in the range 0 to t less than pi here. Okay, we know the limits value 0 to pi. The same way, that is already we can find out the average RMS value from 0 to pi. Okay, like that you can find out the same by using the above formulas. For full wave rectifier output also you can find out the average value RMS values. Okay, half wave rectifier and full rectifier both are very important in case of the university examinations. Please subscribe our channel and share to your friends.